Welcome aboard. My goal here isn't just to teach you Python syntax. Let's be real, you can Google that. My goal is to teach you how to think like a programmer. We're going to focus on logic, on problem solving, not just memorizing a bunch of commands. This whole explainer is about building your foundation the right way.
And this, right here, is our core philosophy. See, anyone can look up what a function does, but knowing why you need it and how to break a big, messy problem down into small logical steps, well, that's the real skill. We're going to nail down the why before we even touch the how.
So go ahead, fire up your favorite editor. It's time to get our hands dirty and actually start building.
Okay, let's dive right in. Our very first tool, the most fundamental thing in any programmer's toolkit, is the variable. This is how we store and manage information in pretty much every program you'll ever write.
So what exactly is a variable? Well, it's just a named container, a little spot in your computer's memory. And this analogy on the slide, it's perfect. Think of a labeled moving box. The label is the variable's name, something like user age, and what's inside the box is the data, like the number 25. You can check what's inside just by reading the label, and you can swap out the contents whenever you want.
Now this is a classic little logic puzzle that every programmer learns. Imagine you have a glass of water and a glass of milk. How do you swap them? You can't just pour one into the other, right? You'd make a mess. You need a third empty glass. And that's exactly what we do in programming. We create a temporary variable. We pour the first value into that temp variable. Then we can pour the second value into the now empty first container. And finally, we take what we saved in our temp variable and pour it into the second container. Understanding this simple logic is, well, it's a huge step. And before we move on, 2 quick pro tips. First, please use descriptive variable names. A name like X tells you nothing, but user age, that tells you exactly what's inside. It makes your code so much easier to read later on. Second, you can't use a variable before you've actually put something in it. If you try, Python will throw a name error and your program will just stop.
So, we have our containers, our variables, but what are we actually putting inside them? That's where data types come in. You see, Python needs to know what kind of information it's dealing with.
For now, let's focus on these core 4. We've got integers, which are just whole numbers, floats, which are numbers with a decimal point, strings, which is just a fancy word for text and they're always wrapped in quotes, and finally booleans, which are our simple logic values, just true or false. And these are super important because they decide what you can do with the data. You can add 2 integers, no problem. But you can't really do math on a string, can you?
Now here is a rule you absolutely have to remember. User input is always a string, no exceptions. So if a user types the number 5, Python sees it as the text character 5, not the number 5. So if you try to multiply that string 5 by 2, you don't get 10, you get 55. It just repeats the text. To do real math, you have to explicitly convert that string into a number, into an integer.
And this leads to 2 super common mistakes. First, just plain forgetting to convert user input from a string to a number, and second, trying to convert something that just isn't a number, like the word apple into an integer. If you do that, your program will crash with the value error.
All right, we can store stuff and we can classify it. Now let's give our code a brain. It's time to start making decisions with conditional statements. Honestly, the best way to think about if-else logic is this. You're at a fork in the road. Your code hits a question, a condition. If the answer is yes, if the sign says bridge out, it takes one path. If the answer is no, it takes the other path. This is what makes a program dynamic, what lets it react differently to different situations. And what's great is that we're not just limited to 2 choices. We can chain conditions together. So here, first we ask, is the number greater than 0? If not, okay, let's ask the next question. Is it less than 0? And if neither of those are true, well, what's the only possibility left? It has to be 0. Okay, pay close attention here, because this trips up so many beginners. A single equal sign is for assignment. It says, put this value into this variable. But a double equal sign is for comparison. It asks a question. Are these 2 things equal? Mixing these 2 up will cause all sorts of headaches, so really let this one sink in. Now we get to the real magic. This is where programming starts to feel like a superpower. We're talking about loops, the key to automation, to doing tons of work with just a few lines of code.
There are 2 main flavors of loops. You use a for loop when you know exactly how many times you need to do something, like running exactly 4 laps around a track. You use a while loop when you don't know the endpoint, but you know the condition for stopping, like, I'm going to keep digging this hole until I hit water.
Now, to work with numbers digit by digit, there are two key math tricks you gotta know. The first is the modulo operator, that percent sign. It gives you the remainder of a division. So 456% 10 is 6, the leftover bit. The second is integer division, the double slash. It divides, but it throws away the remainder. So 456//10 just gives you 45.
Let's put that technique to work. Say we want to sum the digits of 456 using a while loop. On each pass of the loop, we use modulo to grab the last digit, the 6, and add it to our total. Then we use integer division to chop that 6 off, leaving us with 45. Then we just repeat. Grab the 5, add it, chop it off. Grab the 4, add it, chop it off. We keep doing that until the number becomes 0. Two big warnings here. First, if you forget to update your variable inside the loop, like if we forgot to chop the number down, you'll create an infinite loop, and your program will just freeze. Second, a condition like while num greater than 0 is great, but it's not going to work for negative numbers, is it? You always have to think about these weird edge cases and handle them first.
Okay, you've got the tools. You've got variables, data types, conditionals, and loops. Now it's time for your first mission, to combine all of these ideas into one genuinely useful little program. So, here's the mission should you choose to accept it. You're going to build a program that asks the user for a number. It needs to handle negative numbers without crashing. And then, using that digit extraction technique we just learned, it needs to calculate 4 things: the total number of digits, the sum of all the digits, the single largest digit, and the number written in reverse.
And listen, this slide right here, this is probably the most important slide of the whole thing. This is the core of thinking like a programmer. Do not try to write all the code at once. You'll just get overwhelmed. Break the problem down. Step 1, just get the user input. Write that code and test it. Does it work? Great. Step 2, add the check for negative numbers. Test that. Does that work? Awesome. Step 3, build a simple loop that does just one of the calculations, like counting the digits. Once you're sure that part is working perfectly, then you can add the rest of the logic inside that loop. Small, testable steps. That's the secret.
So you've built your foundation. You now know how to store data, how to make decisions, and how to repeat actions. You've used a logical framework to break down and analyze a number. So I'll just leave you with this question. What else in your world could you analyze with this way of thinking? A sentence? A budget? A recipe? See, this mindset, this way of breaking things down, that's the real skill, and it applies to so much more than just code.